So we were talking today a lot about the different shapes, the relationships, and the equations for each one of the different curves. So this is the first one that we looked at in class. And if you remember this one, we made it really easy to remember by drawing a little roller coaster. So here's your roller coaster. And on that roller coaster, we've got, yeah, it's not very good. But anyway, we've got me on the roller coaster. Her hands are up in the air, got really big fingers. Mouth is wide open, screaming as I go down the roller coaster. And because I'm screaming, you know I'm really hyper. So the shape for this one is a hyper. And remember, then we just add the bola to it. So it's a hyperbola. The relationship for this one, if you remember the roller coaster, typically there's a loop on the roller coaster, and so you'll go upside down. And if you go upside down, the other word for upside down is inverted. So if I am inverted, we know that this is an inverse relationship. The equation we typically use for this type of curve, since it's inverse, is y is equal to a over x. And when we want to linearize this graph, we will use y is equal to, and instead of a, we're going to use 1 over x in order to get that to be a linear graph. So we'll go ahead and we will erase all the ink on this slide and go to the next slide. This shape is related to the other shape. So if you remember, here's our hyperbola if we had it. Now you'll notice that we have two sides. And so if we say this is a bowl, we would have a pair. And so this one is a parabola. The relationship for this one we know is quadratic. And because it's quadratic, we use the equation y is equal to a x squared, where a can be any number. And if we want to linearize this, we're just going to say y is equal to x squared. And that makes it a lot easier to convert your data into a line so we can use our slope-intercept form equation. The next one that we're going to use, after we erase all the ink on the slide again, is this one. And if you remember, there's no technical name for the shape. So instead, we're going to call this one Groot. So the name that we give for this shape is called Groot. The relationship, if you recognize it from math, is a square root relationship. And the equation that we use for this one is y is equal to the square root of x. If we linearize it, we can use this equation, or we can just modify the equation and make it y squared is equal to x. Sometimes that makes it a little bit easier to do when you're trying to do this without a calculator, or if you're doing it without the logger program. So those are the three types of graphs that we typically will see, and the ways that we can go through and use the equation to linearize.